And so we have determined the total number of poles on the stator of a 600 volt three-phase 60 hertz squirrel cage induction motor. The running speed then at 1140 RPMs and the rate of slip 5%. Now again, they're typical numbers. Find the total number of poles. So you might already know it. But the idea is to think about the 1140 and the 5%, right? And so remember that the slip is not 5% of the 1140. The slip is 5% of the sink speed, which we don't know because this number here, 1140, we got to assume that these values all comes from the nameplate. So the 1140, of course, is a running speed. So if we start thinking again about the slip equation, then slip is equal to ns minus n divided by ns. And of course, the poles doesn't come up in that equation, but it comes up in the equation for ns. But we don't know ns, right? And so basically now, what we're going to do is think about solving the slip equation for ns. And of course, times 100%, but we don't want to put that in there if we're trying to solve this using algebra. So again, cross multiplication says that S times ns is equal to ns minus n. And if I'm trying to solve it for ns, then I got to, of course, put all of them on the same side of the equal sign. So my negative n, bring that to the left. And I got n is equal to ns. I'm going to bring my s times ns across the equal sign, so that becomes negative. Now ns is a common factor, so I can take it out. And so I think that was where we, had arrived yesterday when we manipulated that equation. But today we want to solve for ns. So ns then is equal to n over 1 minus s. And so in order to figure out the sink speed from the speed, you can't take the 1140 and multiply by slip, but what you got to do is divide by 1 minus the slip. And so for this equation then, we have ns is equal to 1140 RPMs divided by 1 minus the 5%, or as a decimal, 0.05. And so we have 1140 divided by 0.95. And so remember now that we're expecting ns to be a nice whole round number because poles occur in pairs. And so nice whole even round numbers results in that round numbers for ns, right? So ns is equal to 1200 RPMs. So if we know ns, of course, ns is equal to 120 times the frequency divided by the number of poles per phase. And so P comes out to be 120 times the frequency divided by ns. And so therefore we have 120 multiplied by 60 hertz and divided by the 1200 RPMs. And so therefore P came out to be 6. And remember that P is poles per phase, and here we are asked for total poles, right? So now I got really bad in regards to lab marks. I never said really bad, I don't think, that I. And so I don't know if you guys joined late or not, but we'll talk about the lab after we get to this question done, right? So P is 6 poles per phase. So remember that there are 3 phases. So therefore the total poles 3 times P, or 3 times 6, 18 poles total. Now that's one way to do that, right? And maybe that's the easiest way. However, what about if you didn't know that the slip was 5%? Because you know, you can't really assume that it's 5%. It's supposed to be close, but you know, what about if you didn't know that? Well, there's other ways to tackle some of these problems, and you know, I guess it's about thinking about it. But we know that generally N is less than NS, and N is what we're given here. Well, we know that NS is equal to 120 F divided by P. And so, therefore, we can make the argument that N is less than 120 F divided by P. If N is less than 120 F over P, then we can say that P is less than 120 F divided by N. And so our inequality, because N is not NS, but you know, this is following met rules, and so as long as we don't break no rules, we come up with the right answer. And so 120 F over N is 120 times 60 hertz. Divided by the speed, which was 1140. And again, because that speed is not a sync speed, P don't work out to be a nice round number. But we know that P must be an even whole number because poles occur in north-south pairs. So even number, right? Okay, so then this is here 6.3. So our conclusion then is that therefore P is less than 6.3 poles per phase. And so, you know, from that, we need to draw a conclusion about P. And so the reality is that, therefore, P is equal to 6. Now, why can't P be equal to 4 or P be equal to 2? We got to think about it. P is 6, gives a speed of 1200, and that gives a slip of 60 RPMs or 5%, which is what we expect. What about if P was 4? Then that would give us a sync speed of 1800. And if we calculate the slip, it would be like 35, 37%. And we know that that's way too high from what we know about induction motors. But what about if P was 2? Then that will give a sync speed of 1800. And when you compare that to, that will give you a sync speed of 3600. And when you compare that to 1140 for the running speed that you've been given, then that would result in a slip of 65, 67%. And you know that's way too high. And so your conclusion is that P got to be equal to 6. And that means, of course, that the total poles then is equal to 18. Now, if you're doing this for me mathematically, right, and you put down P is equal to 6.3 and then P equals 6, then that shows me that you don't really understand what you're doing, and so that's not really worth full marks. And so remember that this is based on an inequality and a decision because you understand what's going on, right? And so think about that. Now, the other way is that what about if you don't understand the math with that inequality and stuff? Okay, well, think about this. We know that poles occur in pairs, north-south pairs, and so we can figure that there's only a certain amount of speeds available in North America based on, let's say, a 60 hertz system. And, I mentioned before that when it goes off to Europe, the speeds are different, right? And so, that might be a little bit strange there for people to understand, but it's God's truth, right? And so, makes a bit of a difference. And so let's think about the fact that we can always write down this table. And for most part, right, we should understand that this is true. Now, on assignment 4 or 5, I asked you to come up with this table. And so I don't know if any of you have started assignment 4 yet, but, after today's class, we've covered all the material for assignment 4. And so let's think about what those speeds are, right? If we put 2 into this formula with 60 hertz, we comes up with a sync speed of 3600. So for low slip, we're running 34, 3500 RPM somewhere. For 4 poles, you do the calculation. Remember, we talked about the numerator, that being 7200. 7200 over 4, then 1800. 7200 over 6 leaves us with 1200. And 7200 over 8 leaves us with 900. 7200 over 10 leaves us with 720. 7200 over 12 leaves us with 1600. And the next one is 14. And then 14 gives us a number down here that's not a nice round number, 543 or something like that, right? So you can do the math. Okay, so if I got this table and I know that the speed that I've been given is here at 1140, then I know that NS is greater than N, and by not generally a big amount. So what that tells me is that, look, this is the conclusion that I got to draw, right? So therefore, if N is 1140, then I know that NS is 1200, because the rest of them gives me slips which don't fit in our induction motor theory. So that means that I can logically conclude that P is equal to 6, and that the total poles is equal to 18. All right, and so